Alright, this is Lewis Fulterer. This is my code walkthrough for my NEA. I'm just going to go through every file and the corresponding part of the application. So the whole of my GUI is built on this library I've made. Any place in the menus file where it just says button or text or anything, that's referring to this library, which has the buttons, text entries, texts, different selectors, drawing canvases. I don't use that though. Live text updating, different pop-ups, panel selecting. So all of the GUIs are built through here. So when the program starts up, we just open up the window and start the main menu, which is here. We've got the two options for settings menu and playing offline. So if we go into the settings menu, I can bring up the code here. So as you can see, we've got all of the text, which is what appears on the left: settings, board style, piece style, etc. That all appears along here. So these are all the text, and then the selectors and entries are on the right. These just allow you to change colors, so I can change the color of the board to green, for example. The piece styles, you can have as many different piece styles as you want. You just have to have the images saved in. Sound effects, you just have to add any sound effect files. Game styles, again, you can just add different boards starting through the config file or these the board JSON files in here. So you can just add as many in here, and that'll allow you to select them through here. Like I've got the test one, which links to this test board. And then you've got the white and black selectors. So that's just obviously who plays white and black. So these first, Alia and these two are both AIs that I've created. Fire and Stockfish have been downloaded off the internet because I wanted the ability to import engines as well. Time, you can have different time for both sides, and the time increment is universal. So I give them 3,000 to white and 6,000 to black. That's in seconds. And then engine depth obviously only applies if there is an actual engine. So I can give that to Stockfish. And then when we go to play offline, the game is started in main.py. We just create a game class with offline, the config that was selected in the settings, and then the window and the clock. As we start the game, we first load in a lot of the images, load in all the engines, because everything's in a separate file. Here we go, class game. So when we start, yeah, it loads all the config, loads the images, and starts with that. When we run it, it just gets in all the settings, starts up which engines we've selected, resets the time, and gets the GUI ready. So this is the buttons for aborting the game, undo the move, changing the names of the players. So it'll be human or Stockfish for this one. And then the scores for both sides, that's only used if one of the opponents is an AI. It will basically just show their evaluation. And then the pop-up is for if it's checkmate or stalemate or insufficient material. Anything when the game ends, it'll appear on that pop-up. So here, this is while the game is running. This is if it's the engine's turn. This is where it gets the move and calls the Negamax. We've got the events here to if it should close the window, if the player's trying to click, if the player's aborted, if the player's clicked the undo move. And then this is where if the player's trying to make a move, so we've got the selection of which piece they're selected. If they've selected a piece and they've selected a coordinate, it will go and make the move. And this bit here just checks if it's a promotion. Here we've got if the game is not over, then we are updating the time, and we are checking if the game should be over if timeout. So we've got the pop-up coming here if it's timeout. Then we have a lot of the actual GUI being drawn. So after all the processes are done, we draw all the buttons and everything. And finally, some stuff. Once a move is made, it'll switch over whose turn it is. It'll animate the move. It'll check if it's checkmate or stalemate or insufficient material or repetition. And then it just updates the display. And then this is the code for animating the moves. You can decide the frame rate for each animation. This is drawing the board, the checkers itself, highlighting squares. So if the player's clicked a piece, it will highlight which squares it can go to. Drawing the pieces, that's obvious. and then a class for completing games. So once a game is done, it will just save it to a file that can be loaded using Pickle. And then we've got some functions for changing algebra to the coordinates. So I can start that up here. So when we play offline, we've got that. This is the test board that we loaded in. If I go back to default, we've got the normal one, and honestly quite horrifying green colors. You can see the time. I started with 3,000 with 100 increment. I've made a move. Stockfish started with 6,000, so that works. The pieces are animating nicely. And as you can see, we're playing against Stockfish, which is what we selected. If I were to go back to human, it would appear as human, and I'd be able to move both pieces. Just like that. I have an installer, so the first time a program is run, this just loads in the default settings and creates the config file. That's it. And we have a load of saved games here. So these are all just pickle files, which is just a saved object. So if you ever wanted to load them back into the game, that could be added and then done very easily. We've got all the pieces, so they correspond to, they have different numbers for the name. We've got the images, so the 8-bit ones, these aren't loaded in, but you can just download any images and name them whatever you want. And then we've got all the default ones that I do have. For the engines, the 3 that I've done all work relatively similar. They're just slightly different in how well they play the game. We've got a value for all the pieces, a function to get the best move, a function to evaluate a score, the actual Negamax function itself. So this is a slightly faster version than Minimax, and it's also included with alpha beta pruning, which speeds it up by about 18%. I've got a function to sort the moves. Alpha beta pruning works better if the moves are already sorted and ordered, and then this is the code that scores the piece. So we've got adding up the material, if it's checkmate or not, and then also a PSDQ table. And this basically says, well, a knight in the middle is much better than a knight in the corner, a bishop in the corner is much better than a bishop in the center, etc, etc. You know, a king is much better on the corners than it is in the middle. And that's that. For the downloaded ones, it's a lot simpler. I've got a get move thing, which basically just opens up the exe file and asks for the evaluation and best move and just simply returns it. So that's that. Yeah, I think that's mostly it. It's been new for my for the actual game. I use PyChess to handle the board and the piece movements for the speed. An AI using Negamax works a lot better when it can quickly iterate through all the moves, and doing that in just Python is just not really feasible for speed. So the functions I've got here are just converting to FEN strings, undo and making moves, getting a list of valid moves, and then handling the castle rights and whose turn it is. And yeah, that's about it. If I run here, you can see the checkmate pop-up comes up and all the clocks stop. You click OK, it takes you back to the menu. You can select whatever AIs you want, and they just play against each other. Because my eyes are made entirely in Python, they're a lot slower. Stockfish and Fire and all the best ones are made in C#, which is a lot faster. So as you can see there, it took about 11 seconds for my one to move. It evaluated 82,000 nodes, take 10.3 seconds, that's 8,000 a second. Will you open up, please? There you go. And you can see the evaluations on the side. They both evaluate in different times. My one evaluates in single digits. Stockfish prefers to do 1 pawn is 100. And that's that. I'd always run the slower ones on a lower depth to really get the full see the full testing. So as you can see here, it develops the pieces like relatively smart on 1 depth. That obviously sees no consequence to it losing pieces. So it should just get checkmated. There we go. On 2 depth, it won't just throw away its pieces, but it's a little bit slower. Yeah, and that's that. Obviously, it's nowhere near as good as the world-class AIs, but it does the job. So yeah, I think that's most of the code. Close this down again. Opened it up too many times. Yeah, I think that's the majority of the code. Don't really have anything else. We've got all the menus. Oh, it's actually just 3 of them. The game is ready to do analysis, but that's not included in the final build. You can see here, it's started on.